Hello children, today we will see one important topic, mechanics. Mechanics means nothing but study of motion of a body. If a body is in motion, then what is its initial velocity, what is the acceleration of the body, what is final velocity, how much time it takes to go here to there, how much distance traveled by the body, all these things we will discuss now. Mechanics is generally classified into three types. Mechanics is a branch of physics which deals with the study of motion of a body. Mechanics is classified into three types. They are kinematics, number 2 dynamics, number 3 statics. These are the three branches of mechanics. Mechanics is classified into three types: kinematics, dynamics, statics. Mechanics means nothing but study of motion of a body. The study of a motion of a body again classified into three types: kinematics, dynamics and statics. Kine means motion, matics means measurement of the motion. Here also measurement of the motion, here also measurement. Then what is the difference between kinematics, dynamics and statics? Remember, let us consider this is a road. On this road one vehicle is going on. This is a car, one car is going on. Its initial velocity is u meter per second. After some time, this driver raised the speed of the car from, let us consider initially 10, now it is 40. That means the final velocity is v meter per second. Directly, whenever you start the car, directly you cannot go on 50 or 60 or 100 meter per second. Initially the speed will be less. So initial speed is u meter per second. After some time the final velocity is v meter per second. Here to there it takes, let us consider t seconds, and the distance travelled from here to here is, let us consider s meter. Initial velocity of the car u meter per second, final velocity of the car v meter per second. The time taken by the car to travel from here to here is t seconds, and the distance covered by the body is s meter, and the acceleration, change in velocity, is v minus u by t is called nothing but acceleration, rate of change in velocity. Let us consider initial speed is 10 meter per second. Now the speed is 20 meter per second. How much time it takes to reach 10 to 20? Let us consider 2 seconds. After 2 seconds, the velocity changes from 10 meter to 20 meter. So final velocity 20 minus 10 by 2. 20 minus 10 is 10. 10 by 2. 2 ones, 2 fives. That means the car is traveling with 5 meter per second square acceleration. Acceleration is 5 meter per second square. That means if initial velocity is u meter per second, final velocity is v meter per second, the distance travelled is s meter, time is t second to reach here to here, acceleration is v minus rate of change in velocity. Only these 5 terms we use in kinematics. That means initial velocity u, final velocity v, time t to reach here to there, distance s, and acceleration a meter per second square. Only these 5 terms we use in kinematics. We don't consider force term. What is initial velocity, final velocity, time taken, distance traveled, acceleration. Who applied that force? What type of force is applied on the car? What is the frictional force? What is the normal force? All these things we will not discuss in kinematics. Kinematics only we deal with initial velocity, final velocity, time taken to reach here to there, distance travelled by the body, and acceleration. Only these 5 terms we will consider in kinematics. In addition to that, these 5 u, v, a, s, t, including of these 5, if you consider force also, that comes under dynamics. Dynamics means all including of kinematics plus extra force. So force, who defined force? Force defined by Newton. So that most important concept, Newton laws comes under, Newton first law, second law, third law comes under dynamics. Understand? Here we don't consider force. Here we will consider force also. If you consider force also, that is called dynamics. In statics, there are so many forces acts on a body. Let us consider one body is here. Now, Earth is pulling downwards from the center of the Earth, from the center of the object to the center of the Earth. This is called gravitational force. Gravitational force is nothing but weight of the body. Weight of the body is mg. Similarly, how much weight is downwards, that much force is upwards. This is called normal force. There is a friction between there are small obstacles between object and this surface. This is called nothing but a frictional force. Frictional force opposes the relative motion. If this body is constant, if the body is at rest, means the sum of all these forces is equal to 0. The net force applied on the body is 0. If your body is at rest, means that doesn't mean that no force is acting on the body. Let us consider this is a wall. This wall is at rest, means that doesn't mean no force is acting on the wall. This chair is at rest. That doesn't mean that no force is acting on the chair. So many forces acting on that. Earth is pulling downwards. That means gravitational force will be downwards. Normal force will be upwards. Normal force is always equal and opposite to the weight. And some frictional force is present. Air force is present. So many forces are present. But the magnitude of all these forces must be equal to 0, so that the body is at rest. If a body is moving, means some extra force is applied on the body beyond all these forces, so that the body comes into rest. All these are some important and effective topics we will discuss in this session. Today we are going to see kinematics. In kinematics, so many numericals we will get. All those numericals we will do one by one. In how many videos it comes, I too don't know. Today we will see only basic formulas in kinematics. Understand? Right, okay. Before going to see kinematics, I am Satish Kumar sir. Our channel name is Physics for All, Parvatam Satish Kumar. Type in YouTube Physics for All, Parvatam Satish Kumar. Watch all these videos. Write notes clearly. Take a notes and paper and watch carefully. Pause it and write again and again. Right. Our today's topic is kinematics. Kinematics. Matics means measurement. Kine means motion. It is a Latin name. Kine means motion. Matics means measurement. Measurement of motion. Kinematics. Now, as I said, in this chapter we are going to deal only with initial velocity, final velocity, time, and distance and acceleration. Only these 5 terms we will use. Now, first of all, we will see all formulas at a time. Then after we will see derivations. This is a road. On this road, one vehicle is going on. One car. Imagine a car. Its initial velocity u meter per second. After some time, it goes here to here. That means the distance traveled by the car is s meter. Here to here, the distance is s meter. Final velocity v meter per second. The time taken here to here is t seconds. And the rate of change in velocity v minus u by t is called nothing but acceleration. Acceleration unit is a meter per second square. This is what these are the 5 terms we will use in kinematics. Initial velocity u, final velocity v, acceleration a, time t, and distance traveled by the body s. See, if a body maintains equal v minus u by t ratio is here, that means the car, let us consider in 2 seconds the acceleration is, in example we saw, in 2 seconds the acceleration is 5 meter per second square. In 2 seconds it travel up to here. Next 2 seconds also it maintains same acceleration. That means in next 2 seconds also, if acceleration is 5 meter per second, then it is called uniform acceleration. Remember, uniform acceleration means v minus u by t ratio is constant. If v minus u by t ratio constant, then the body is said to be in uniform acceleration. Now I am going to write the equations for uniform acceleration. Uniform acceleration equations are. What are uniform accelerations? Remember, v is equal to u plus at. S is equal to ut plus half at square. V square minus u square is equal to 2as. Sn is equal to u plus a into n minus half. These four equations are called uniform acceleration equations. Very, very important. Uniform acceleration means if rate of change in velocity is constant, then the body is said to be in uniform acceleration. Let us consider this car is in uniform acceleration. Then these four formulas are applicable. Number 1, v is equal to u plus at. Number 2, s is equal to ut plus half at square. Number 3, v square minus u square equal to 2as. Sn is equal to u plus a into n minus half. These are applicable for uniform acceleration. That means if a body is going on the road with constant acceleration, these formulas are applicable. Now, upward thrown body we will see. Upward thrown body. Vertically upward thrown body. What is mean by vertically upward? With respect to ground, it is making 90 degrees angle with the earth. Exactly upwards, vertically upwards. It is maintaining 90 degrees angle. Object is thrown upwards. Then what are the equations? What equations are applicable for upward thrown body? It is not a constant acceleration. Why? Because if you throw a ball upwards, what will happen? Gradually its velocity decreases. After some time its velocity becomes 0. At a particular time of instant, the velocity becomes 0. So that what will happen? Its initial velocity u meter per second. It is in the path. Let us consider object is here. At this point its velocity v meter per second. V is not 0. Why? Because I did not say it reached the maximum height. Just it is going up. In the middle of the path I am considering its velocity is v. Now how much time takes here to here? Let us consider t seconds. Now distance is not denoted by s. Here it is height. Why? Because it is going against the gravity. S equal to h. Gravity is minus g meter per second square. Why? Because earth is pulling downwards. Object is going upwards. Object is going vertically upwards, but the gravity, earth is pulling downwards. That means it is going against the gravity. So instead of a, you have to take minus z. Substitute all these values in this formula, you will get upward thrown body. Now fifth equation. What fifth equation? V is equal to u minus gt. Fifth equation. Sixth, in place of s, substitute h. H is equal to ut minus half gt square. Number 7, v square minus u square is equal to minus 2gh. Last one, hn is equal to u minus g into n minus half. These four equations are called upward thrown body equations. If a body is thrown up, you have to apply these four equations. Once again, I replaced a as minus g. In place of a, I substituted minus j. S plus h, remaining all a plus minus g. That's all. Remaining all common. This equation we use if object is traveled in nth second. Sir, when do we use first formula? Suppose in a problem s is not given, you use this formula. Suppose final velocity is not given, use second formula. Time is not given, third formula. A body travels 10 seconds. What is the distance travelled by in 8th second, 6th second, particular second I want? Then we have to use this formula. That means to find nth second we have to use this formula. Remember, s nth is equal to u plus a into n minus half. H nth height, h nth is equal to u minus g into n minus half. These are uniform acceleration equations. These are called upward thrown body equations. Now we will see freely falling body equations. Number 3, what are freely falling body equations? Let us consider a body is freely falling. By default, remember, when the body falls freely, if it reaches the maximum height, then only it comes back. If you throw a ball upwards, it goes to the maximum height. Gradually its velocity decreases while going. At a particular instant its velocity becomes 0. Then after it comes down. That means freely falling body means its initial velocity is 0. When it is coming down, acceleration is plus g you have to take. Why? Because it is coming towards the gravity. S is nothing but height from maximum height to the ground. It takes t seconds, so in place of t you take t seconds only. Final velocity is v meter per second. Just before reaching the ground, its velocity is maximum. Just before reaching the ground, its velocity is maximum, so v meter per second. Substitute all these values in the standard formula, uniform acceleration equations. U becomes 0, v is equal to gt, h is s plus h is equal to 0 and half gt square, 0 plus half gt square, v square minus 0, v square equal to 2gh, h nth is equal to u0, g into n minus half, right here. V is equal to gt, h is equal to half gt square, v square is equal to 2gh, h nth is equal to g into n minus half. These are called freely falling body equations. This is equation number 5, 6, 7, 8. This is 9, 10, 11, 12. Remember these 12 equations. You no need to by heart. Simply remember these 4 equations. You will get remaining equations automatically. Freely falling body, initial velocity is 0. Acceleration is plus g. S is equal to h meter. Time equal to t seconds. Velocity just before reaching the ground, v meter per second. This is equation number 9, 10, 11, 12. Once again, uniform acceleration equations are v is equal to u plus at, s equal to ut plus half it square, v square minus u square equal to 2as, sn is equal to u plus a into n minus half. These are called uniform acceleration equations. Upward thrown. If you throw a body upwards, acceleration becomes negative. So a is equal to minus j, a is equal to minus j, and s equal to, in place of distance you have to take height, t equal to t seconds, remaining all same. Substitute here, you will get v is equal to u minus gt, h equal to ut minus half gt square, half gt square, v square minus u square equal to minus 2gh, hn is equal to u minus g into n minus half. Suppose freely falling body. When the body is said to be freely falling, if its initial velocity is 0, then we can say it is a freely falling body. Freely falling body means it reached the maximum height, or if you drop a stone from 5th floor or 4th floor, it is called initial velocity. Without any initial velocity, if you drop, we call it as freely falling. Initial velocity 0. A equal to plus g. Why? Because it is coming towards the gravity. Earth is pulling downwards, body is coming downwards, both are in same direction, so A is plus g. S equal to h meter, t equal to t seconds. Just before reaching the ground, its velocity maximum, v meter per second. If you substitute all these values in the standard equations, v is equal to gt, h is equal to half gt square, v square equal to 2gh, hn is equal to g into n minus half. These 12 equations are very important only for vertically thrown upwards, vertically coming downwards. That means it is making 90 degrees angle with the earth. If it is projectile, then it will be different. The projectile equations also we will say. First remember, uniform acceleration equations are v is equal to u plus at, s equal to ut plus half it square, v square minus u square equal to 2as, sn is equal to u plus a into n minus half. Upward thrown body equations, v is equal to u minus gt, h equal to ut minus half gt square, v square minus u square equal to minus 2gh, hn equal to u minus g into n minus half. Freely falling body equations, v is equal to gt, h is equal to half gt square, v square equal to 2gh, hn equal to g into n minus half. Now see, projectile, 13th equation, projectile motion. What is mean by projectile motion? Projectile motion. Suppose this is what a horizontal path. One football is here. I kicked the football. What is the path of the football? Football goes like this. This is called parabolic shape. Football goes like this. This is the path of football. This is what x-axis. This is x-axis, this is y-axis. Now let us consider the velocity of the football is in this direction. Let it be u. This is the velocity of football, v, u. Now it is making theta angle with the x-axis. Let it be theta. Now what will happen? This will be u cos theta. How u cos theta? I will tell you. This will be vertical component will be u sin theta. The velocity in the path of projection is u. It is making theta angle with the x-axis, so it is horizontal velocity is u cos theta, and the vertical component will be u sin theta. U cos theta never changes. U cos theta is always constant. Why? Because it is in horizontal path, its velocity do not change. While going up, velocity gradually decreases. So u sin theta decreases here. Here u cos theta is constant. U sin theta again decreases. At maximum point, u cos theta do not change. U sin theta becomes 0. There is no u sin theta. Why? Because at maximum height, velocity 0. Vertical component will be 0 at this point. At maximum height, u sin theta 0. Again, when it is coming back, u cos theta constant. U sin theta again increases. At minimum point, u cos theta same, but u sin theta maximum just before reaching around. That means here remember, u sin theta vertical velocity of the projectile motion while going decreases, while coming down increasing. But u cos theta is constant. So that we need vertical velocity here. That means in place of u, you have to substitute u sin theta in projectile motion. In projectile motion, just remember, if kicked football is the example for projectile motion. If you kick a football, the ball goes in a parabolic path. Horizontal component do not change, but vertical component changes. Vertical component gradually decreases up to maximum extent. From maximum point to downwards, vertical velocity gradually again increases. In depth, we will see after the derivation of maximum height, after the derivation of time of ascent, time of descent, these equations we will see. Copy it once. Right, these are constant equations, standard equations, so we need these equations for each and every derivation, so I am not going to wrap. Now next topic is equation for maximum height. Equation for maximum height denoted by h max. What is maximum height? Suppose this is ground. I thrown a stone upwards with vertically upwards, that means with 90 degrees with the ground. How much height it goes? What is the maximum height? We cannot measure with the tape, no? Then how can you find the maximum height? Suppose I thrown a body vertically upwards with 90 degrees angle, exactly I thrown a body like this. Then how much height it goes? We have to find the h max. To find the h maximum, we need to know initial velocity. Let us consider I thrown a body with u meter per second, 10 meter per second. You thrown a body with 50 meter per second, then it goes maximum height. I thrown only with u meter per second, let it be u. You don't know, u varies. Why? Because I may throw with 10 meter per second, my daughter may throw with 5 meter per second, you may throw with 50 meter per second, like that, so that at maximum height final velocity becomes 0. For upward thrown body, a is equal to minus g meter per second square. Then what is required? Distance is equal to nothing but h maximum. How much height it goes? In place of s, write h maximum. Now we no need time. Why? Because time I am not taking. Why? Because time varies with initial velocity. I may throw with 10 meter per second, you may throw with 20 meter per second. That means maximum height depends only on initial velocity, not on the time period. So that without time, which equation is useful in these three? Why? Because this is exemption only in nth second. So if time is not there, we have to use third formula. V square minus u square is equal to 2as. What is V? 0. 0 square minus u square is equal to into a value minus g into h max. 0 minus u square, 0 minus something. What is something? Minus u square. Plus into minus, minus 2g h max. Minus cancel. H max equal to what? u square by 2g. Important formula. Maximum height without directly you can calculate from the ground. If you know initial velocity, if you throw a ball with 10 meter per second, suppose initial velocity is 10 meter per second. I thrown a body with 10 meter per second up, vertically up, then u square 10 into 10 by 2 into g value actually 9.8. But for our calculation, easy calculation, I am taking 10. 10, 10 cancel, 2 ones, 2 5s, it goes to 5 meter height. How much height it goes? 5 meter. Simple. Suppose if you thrown a body with 100 meter per second, you have more muscle power, you thrown with 100 meter per second. 100 into 100 by 2 into 10. 1 0 1 0 cancel, 2 ones, 2 5. It goes to 500 meter height. That means maximum height depends on initial velocity. Remember, important. So maximum height is directly proportional to initial velocity square. G is constant. Of course, small variations will be present from pole to equator. So almost we will take 9.8 on the earth. Maximum height mostly depends on initial velocity. Maximum height is directly proportional to u square, initial velocity square. Write a note here. Note. Maximum height is directly proportional to square of initial velocity. Important, remember. Once again, maximum height. To find maximum height, we need to know initial velocity. If you thrown a ball with 90 u meter per second, then how much height it goes? U square by 2g. Why? Because at maximum height, final velocity 0. U is minus g meter per second square. Maximum height we don't know. That s equal to h maximum we are considering. Time not required. Why? Because time depends on initial velocity. I may throw with some velocity, you may throw with another velocity, your friend may throw with a different velocity. So I am not considering time period. Time is not there, means we have to use third formula. So maximum height is equal to u square by 2g. So h max is directly proportional to u square.